All right, should have the audio working, camera certainly on. So somebody asked for law of cosines work, a rapid fire, bunch in a row. I think I'll do 4 of finding the angle and 4 of finding side length. Okay, so we'll start with the first one here. And the first one, finding side length, comes from knowing an angle when trapped between 2 side lengths. That's a pretty common problem. And finding an angle, we work with the ratios. Okay, so when you're trying to find an angle, you need this language system, and therefore that has to be a ratio. When you're using an angle, then this has to be a square root. All right, so keep that in mind. I'm going to do 5. I'm going to do 4 of this type and 4 of that type. Let's get some more room on my desk here so I can move the camera easily, computer easily. Okay, it should be up and running. And I think the best way to do this is to follow the first one. You can try it on your own if you think you already know how to do it, but you're asking for the video, so I'm assuming that you haven't quite learned it yet. So how do I get that angle? Well, I know it's cosine inverse of a ratio. And so that angle is opposite 9. That goes in this position. And then we simply work with somewhat of a Pythagorean type model. That's about square areas. And 2 times 5 times 6. Okay. The last one I'm going to do, we'll change the 3, 4, 5 triangle a little bit and actually look at the numbers and how they kind of interact. Right. So that's problem 1. I'm going to stick with this now. Change the numbers, change the look, and you find the angle that I asked you to find. All right, so let's see. I'm not that great at drawing these things. Let's draw something that's fairly, certainly not 90 degrees, that angle. And let's make it go, that looks like 90. A house, that they all look like 90 to me. Let's go up and down. That's better. I think that's better. So we're going to find this angle, which means that I have the 3 side lengths, right? So what do we got? Maybe 7. And that looks like if that's 7, maybe 10. And so maybe this is it's near 7. So I'm really not sure. Let's call it 8. Okay, but I'm after this angle right there. So I want you to remember that. So what do you start with? Got to make a ratio out of this to find that angle. So cosine inverse of a ratio equals an angle. Fraction. What do I put at the end? 8 squared, and it's minus. Then you're working with 7s and 10s the rest of the way. 7 plus 10 squared minus 8 squared over 2 times 7 times 10. Okay, so there's our second one. We'll do 2 more. I won't allow you to do right triangle trig. I don't want you to do right triangle trig, but let's do it for a 3, 4, 5. That's 4, 3, 5. We know that's 90 degrees. Let's hopefully see it work out to 90, and then we'll change it slightly so we can see how it becomes a bigger angle. So we're trying to find that angle. We better get 90 degrees out of this. So you've got 3 side lengths. Again, cosine inverse. Opposite the angle is 5. So minus 5 squared. That gets us 3 squared plus 4 squared. All over 2 times 3 times 4. Let's actually do it out. 25 minus 25 is 0. 0 divided by anything is 0. And what is the cosine of 0? Cosine of 0 is the width. When am I 0? When I'm straight up, 90 degrees. Okay. Now let's open this up a little bit. 3, 4, maybe that's 4 units. 4 units, okay. And now we have something bigger than 5. So if that's 7, let's call it 6. It's got to at least be less than 7 or I can't draw the triangle. All right, so let's find angle A. Again, you're pausing the video. I'm just writing it out. Cosine of fraction minus 6 squared. I'll put it a little further. Repetitions, my friend. 3 squared plus 4 squared minus 6 squared over 2 times 3 times 4. So let's get an estimate of this angle by actually doing it ourselves. So 9 and 16, 25 minus 36 is minus 11. 6 times 4 is 24. That's not really 1/2, but it's really close to -1/2. So let's do -1/2. Okay, what's the cosine inverse of -1/2? Well, I hope you're drawing that triangle, and I hope we've done enough work to know that that's 120 degrees. Does it look, I mean, I estimated 130. These are gross estimations, right? So, and this, remember, was an approximation too, but it's putting us in the ballpark. I don't know why I'm showing that diagram. Been up so a long time today. Okay, should be looking at this diagram. This triangle is not the one we were analyzing. So does it look like it might be near 120? Of course, you're going to put it in the calculator, -11/12, right? Over 24, sorry. Right, you're going to put that in the calculator. Go to Google, ask for an inverse cosine calculator. Just type inverse cosine calculator, and you'll get something with an open parentheses, and you put the ratio in one last time, opposite that, trying to find that. So you just put 3 squared plus 4 squared minus 6 squared. Hopefully you can do it in that order. 2 times 3 times 4, and let the machine tell you what the angle is, because I don't know. Right? The only ones we know right now are the 30, 40s, 45, 60, 90s. And that's what we've been working with. All right, so the other type of problem is finding a side length. A side length, a length must come from working with numbers. And how do we work with numbers? Well, we put the cosine of an angle in, and you've been given an angle. So now we can find out what this length is if we know the law of cosines. And the law of cosines, we'll just call this length L. All right, so what does L equal? What's the formula I want you to learn? Well, first off, we want a square root because it's a distance. Right, this is where the Pythagorean theorem comes from. Pythagorean theorem is a special case of the law of cosines. I think we just analyzed it a moment ago with the 3, 4, 5 triangle. So I'm going to work with all of this information. Okay, 5 and 11. 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 130 degrees. Remember, we said that's near -1/2, yes? So you would get 110 times -1/2 minus 50, and you put that with these, and yeah, you get your distance. Maybe I'm almost done with this. So this is 121.25. So that's 146 minus 50, which is 96. So we take the square root of 96, a little less than 10. Doesn't look like, yeah, no, that looks wrong. So, but this was a real butcher here. I don't know what that value is. That's going to be more like negative, instead of -0.5, it's going to be more like maybe -0.6. So I kind of butchered that a little bit. You'd have to do it on a calculator. All right. And if that number is not less than 16, it doesn't exist. So I butchered something here, but let's just get the mechanics down. We can do one together in the classroom with the calculator. So let's change this picture. Let's do the 3, 4, 5. All right. And if this was in standard position and I gave you a 3 and a 4 and I wanted that angle, remember, I'm looking for tan inverse of the ratio 4 to 3. That's what you got to write. Okay. But to prove that this is 5, I think would be useful. So let's do a 3, 4 and find the number 5. Okay. So you've got 3 pieces of information. What are you going to do with it? You're going to start with a square root because it's a length. You're going to do 3 squared, and you don't have to say 9. You don't have to add these up. Just write down the following on your answer keys. 4 squared minus 2 times 3 times 4, because this isn't useful to you unless you memorize it. Cosine of 90 degrees. Well, what is the cosine of 90? We just did it a minute ago. Straight up, it's 0. There is no width. 0 times anything is 0, and there's our 25, and the square root of 25 is 5. Okay, so law of cosine works for all triangles, but when I give you a 90-degree triangle, we spent a lot of time on 90-degree triangles, you use right triangle analysis. All right, so let's see, can I draw another one here? Let's draw something. All right, so that's a small angle. Maybe we can call it, I don't know, let's call it 25 degrees. Okay, I think it's smaller than that, but let's start with 25. Let's make this 7, let's make this 6, and let's see what that is. Okay, so what's that length? You're pausing the video, I'm just doing it. Length is going to come from a square root calculation. I'm looking at 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 25 degrees. Okay, so somebody's attacking us from the other classroom. Let's do one more. I lost track of how many we've done, but hopefully you're already gaining some skill with the mechanics. Okay, notice I'm not even saying A, B, C. So let's do it with A, B, C. Side A. Side B, that's definitely more than 90. Side, now I don't want to give you side C, okay, but let's go with what side C would be. So that looks to be about 150 degrees, maybe 150, 147 degrees. We'll go with 147 degrees. Okay, so what's side C? Well, you got to have a square root. Can you see that? Yes, you can. So you're doing A squared plus B squared minus 2AB cosine of 147 degrees. Running out of gas here. All right, and I probably should have done the same thing for the other one where we're finding an angle, because there's obviously, let's go back to this. You start with C, then you end with what's opposite C. Okay, so this is cosine of big C over here. All right, so if you draw a triangle, here's a triangle, and this is angle A, and that's little a. This is B, that's little b. If this is C, then that's big C. If this is big C, then this is little c. All right, you have to know that, or this formula is not going to be any good for you. If I say A equals 2, B equals 3, and C equals 4, unless you know how to figure out what is opposite angle B. Okay, what's opposite angle B? 3, and now we're going back to the original ones we were doing, and we're trying to find an angle. What language system comes from an angle? Cosine inverse. So that's going to be B, so I know I end with 3 squared. So 2 squared plus 4 squared minus 3 squared over 2 times 3 times 4. You get the calculator out, you put that in, and you can go to Google, you can type it right on the, whatever you call it, the entry line of work. Probably would do it for you there. Or again, ask for an inverse calculator from Google and you'll get one in a minute. Well, quicker than that. All right, so I'm rushing obviously because I got another place to go, but hopefully that's a little practice that's helpful. All right, see you tomorrow.